Hi everyone, so my name is Stanislav Dombrovsky. I work at JetBrains in AppCode team. And today I'm going to talk about the ServerSide.swift if we're writing an IDE for it. So we will talk about the integration of the cross-platform Swift into the IDE by itself, and also about approaches used for integrating the things specific for the server-side-swift. When preparing this talk, I've used the following tools. So it's Xcode, AppCode, and CLion, maintain Swift development environment extension for the VS Code, IDE Swift and Nucleate extensions for Rater, and also such tools as Sorcery, Refactorator, and SourceKit. I've used them for investigating some problems. So what do we need to integrate the server-side-swift into our IDE? First, we need to understand how all our sources are connected into a project, which relationships exist between them. So we need a project model. And as a project model, the obvious choice will be a Swift package manager because it has so many benefits. It has a cross-platform project structure. And as soon as we can load our project and understand all the various relationships between our sources and tests, we need to write our code, and here we need a code engine. As a code engine, we will use the SourceKit. Or, of course, we can write our own engine, but that's very difficult and sometimes almost impossible for the third-party integration. As we can now write our code, we need to build, run, and debug and test it. And here the combination of the LLDB together with Swift Package Manager will help us. Also, we need this IDE to work on macOS and Linux. We not work only on macOS right now. And finally, we need some integrations specific for the server side, like databases, request testing, and many others. But first, let's talk about the language part. We decided to use the Swift Package Manager as a project model. And for integrating into the IDE, it has several important benefits. So the first one is that the project structure itself is based on the file system. So you don't need to deal with such strange things like groups without folders, folders without groups, as you sometimes have in Xcode projects. So only folders, only files. Also, it has a unified source layout. You have all the sources inside the sources folder, all the tests inside the test folder, a build folder with build artifacts, and the checkouts folder for the dependencies, and the package Swift, our representation of the project model. And the great benefit for the package Swift is that it's a Swift file, so we can edit it as a code. We don't need something like this. We can edit it as a regular code, have some code completion, code highlighting, and we can have it. We're an IDE working with the Swift language. And finally, we use a zero-wizard approach, so we don't need to maintain the complex UI. That is also great for integrating it. If we take a look at the current state, we will see that VS Code and Atom integrations can open the Swift Package Manager project as a folder. They do not deal with the package Swift project model. CLion, for example, can load it as a project, but it also doesn't deal with the package Swift. It uses the CMake wrapper just to perform all the actions required for loading the projects, resolving dependencies, and so on. And also, in none of them, we have a code assistance inside the package Swift. And here goes the question, why? To work with our project model, to work with it as with the code, we need a code engine first to resolve all the different entities inside our code and have a code completion and navigation, for example. And as we are using the SourceKit, we also need this project model we are trying to build for the SourceKit to work. So we need a project model to build a project model, and that sounds like a problem. That's not a problem indeed, but to understand why that's so, we need to first talk about the code. And for the code, we decided to use the SourceKit, which is available on macOS and Linux, which is great. Also, it's really easy to integrate because it uses a quite simple key-value protocol. So you can easily integrate it into any third-party IDE or the text editor. And also, it has a service client architecture. So you have a language backend providing you with all the code assistant actions and you can call them from your front end, from your IDE. It has many different features indeed. We can build a code highlighting using the source request editor open request. We can have a documentation for the specific symbol in our code with a source kit. We can show the code completion, display warnings, errors, and even fixes, which are code transformations because we have all the needed informations. We have ranges for replacement. We have a message to display for each fixit. So we can display it in the same way as Xcode does. We also can perform a navigation when we generate the Swift module interface using the source kit, and we can navigate, for example, to some standard library symbol declaration. We can perform a code formatting, and actually much more. And indeed, a lot of these features are used by current integrations. If we take a look at the current state, we will see that in Atom integrations such as IDE, Swift, and Nucleate, we have a code completion and highlighting. Only the code completion works via the source kit. In the VS Code, we have much more. We have code completion, highlighting, documentation together with error reporting. But again, only code completion and documentation work via the source kit. The highlighting is performed using some custom grammar, and error reporting is built using the build output from the Swift package manager. In CLine and AppCode, we don't use the source kit for any code assistant actions except displaying warnings and errors and fixes in the same way as in Xcode. And we also have our own transformation actions. And obviously, Xcode does the opposite. It uses the source kit for all the navigation actions and all the code assistants. Together with all these benefits, we indeed can build a complete code assistance using the source kit. We have several problems I also investigated when preparing these talks. First is the problem with dependencies. So if you take a look at integrations working directly with the Swift package manager projects, such as integrations in Atom and VS Code that use the source kit for building the code assistance, we have problems with dependencies, such as if you try opening a simple project, we have a code completion, have a documentation, but if you start working with a simple Vapor or Kitura project, we have none of them. Seems like we have problems with the resolution for symbols from project dependencies. And talking about the package Swift, why don't we have a code assistance? Because the package description is also a dependency. It's a separate module, and all the code constructs inside the package Swift come from the package description module. So to have the code assistance working for our package Swift, we also need to take this dependency into account. Also, there are many discussions about the source kit performance. So like it's slow, it consumes a lot of CPU, but let's now take a look if it's really true. When preparing this talk, I was needed to investigate all these issues just to see how all these integrations are intended to work, because the goal was not to say something like, this doesn't work, okay. And how they are intended to work is totally okay, but they miss such important thing like compiler arguments. For the source kit to work, you need to submit a totally correct set of the compiler arguments, the same compiler arguments that Swift compiler uses for building the specific file. This compiler arguments is another representation of the project model. So source kit knows which dependencies your project has, which information he needs to take into account to build all the code assistant actions. And here, if we do not submit all the compiler arguments, we can miss some dependencies, can have some false warnings and errors and so on. Or the code completion or any code assistance won't work at all. And here we have a solution. So the solution will be to first build the project, to get all the dependencies. Next, we need a debug YAML file inside the build folder, which contains all the compiler arguments for each code file in our project, specified for the specific module in our project, because submitting the module name is also very important if we, for example, trying to invoke the completion. Next, we can parse and cache it. in the same way as Nuclid does for now. And finally, we combine the set of compiler arguments like the module name with some arguments, a build debug folder because it contains all the dependencies for our projects and we need to submit it in the same way as Xcode does, and compiler arguments for the specific files. From my testing, using such approach allows to get the correct code completion for dependencies in any of these extensions, actually. Next, about the performance. So, is the source kit really slow? Does it consume a lot of CPU? In fact, not that much. Because if we take a look closer to these integrations, we will see that there are some problems in the implementation. And the solution to significantly improve the performance of each of these extensions will be the following. So first, try to make the part communicating with the source kit a service. So it keeps only one instance of the source kit service running at a time, because for some of these extensions, that's a problem. Next, try to handle errors and timeouts carefully, because some of these extensions do not restart the source kit service if it's crashed, or it's stopped, or it's killed from the activity monitor by you, for example. And another dimension of always have one process suggestion is when we use the source kitten tool for performing the source kit requests, because it's really easy to use it for dealing with the source kit. For example, it's used in IDE Swift and Nuclid extensions. When we use it and perform a separate request to the source kit on each change in our code file, if we type very fast, we will have a lot of source kitten processes. And each of these processes starts as separate source kit service process. So we have a lot of source kit service processes also. And it leads to high CPU, for example, and to very, very slow auto-completion. So just a simple tracking of all the previous processes, because we don't need them, we need results only from the latest one, improves situation a lot. Talking about the code, we can also need to take into account the code generation, refactorings, and navigation. And here the situation is much more difficult, because to say build a simple code generation working in the context of the whole project, we need to take into account all the standard libraries and all the third-party dependencies in our projects. So if we are using the source kit for that, we will need too many source kit requests, and it's very slow, not because the source kit is slow, but because we need thousands of such requests for just the standard library with all the modules and all the submodules here. We first need to load it using a separate request. Next to receive the syntax and semantic information, next we need to cache it. And here we need an indexing and cache system to perform it fast. That's, for example, the case for sorcery and refactorator. Sorcery needs a cache system but does not have it yet for its templates, to compare your own symbols in your templates with standard library symbols, for example, or with symbols from third-party dependencies. Refactorator needs a cache system and actually uses the Xcode cache system to perform a fast rename refactoring in the context of the whole project. Xcode actually has its cache system in the form of the LMDB, a Lightning Memory Database. That's a key-value database, and it communicates with it via the private source kit framework, which is not open-sourced, and also contains requests for global and local refactoring, such as extract method and extract variable, and has an Objective-C and C and C++ support. Also, there are some index requests in the official source kit documentation, but the problem is that they do not work for the Swift Package Manager projects for now. So if we try using the Swift Package Manager as our project model, we now have no caches, we need to write it. And that's also very difficult. That's thousands of man-hours. So, sorry, no code generation, no complex refactorings for now. Situation is a bit better with building, running, and debugging the source code, because Swift Package Manager and LLDB are really easy to integrate. And that's why, for example, in the VS Code, we have this great UI, have a separate plugin working with LLDB, and we have watches, breakpoints, here, separate views. We have it integrated into our editor, and I can say that among the text editors, VS Code had the most configurable approach for debug configurations, where you can set up nearly everything. Atom integrations work with LLDB mostly from the command line, because for now, for some reason, the Nuclid integration for an LLDB, which has much richer support, doesn't work on macOS with LLDB. That's strange. They need some VS Code LLDB extension to work, and it's not ready yet, so you can't use it. In AppCode, CLine, and Xcode, we have everything integrated. But the real problem is that AppCode and Xcode do not work with the Swift Package Manager projects directly. They use the Xcode project model. And CLine for now does the same. It uses the CMake to load the project model. So all these integrations are not for us who want to use the Swift Package Manager. Situation with tests is a bit worse. We can only run tests from Atom and CLine integrations. We can run and debug them in the VS Code because of its configurable approach for debug configurations. In Xcode and AppCode, we can run debug tests, have test UI, but again, we have all of this not for SPM projects. And also with tests, we have one important problem with generated test names when we talk about the Swift Package Manager. So if you're using such framework like Quick, you have all the test names generated at runtime, and it looks like the Swift Package Manager can't list them, can't filter them, and cannot run a separate test. That is possible for regular XC tests. So you can, cannot, for example, list all the tests to display them in the UI. This situation is to be improved from both sides, from the language developers and from IDE creators also, because we need it to be integrated into the UI, we need separate views for tests, and even more. And here we can already formulate how, for example, language developers can help us tool creators. So first, it would be great to have an open source cache system working with the source kit, and that has a good integration and that has an open documentation, because that's critical for making complex code transformations when you're trying to create your own integration for the cross-platform Swift. It would be great to have more source kit requests open sourced, and also not in terms of the language, but also for some IDE actions, because, for example, in the Xcode, such actions like open quickly, such views like symbol navigator are also source kit requests, but they are not available in the open source part. So it would be great to move it here so everybody can use it. Also, one of the suggestions is to decouple all the actions required for building the UI, such as displaying tests, maybe building the list of the build phases from the Swift build. So for now, to list tests, you need to first build the project. And that's not that great. And as the last step, maybe we will need a work group in the future connecting developers in the community, those who make tools, code generation tools, IDEs, who maintains integrations for Swift in text editors, connecting also Swift Package Manager developers and the language developers, because some things that are looking okay from the language perspective can be not that okay from the IDE perspective. And it would be great to have a common direction. Some action points. So when I worked on this talk, I decided to make separate small contributions. So it was a solution how to deal with dependencies for SDE, and suggestion to reuse the Nuclid approach, suggestion how to debug unit tests, because it wasn't clear for the plugin author how to do it and how to set up it. Same suggestion for IDE Swift. The same suggestion about dependencies, small patch for auto-completion to Nuclid, because auto-completion didn't work at that time, and also I tuned a bit the set of compiler arguments submitted because the module name was missed from them. Also, I shared the information about LMDB2 refactorator, because previously Xcode cache database was using SQLite database before the Xcode 9. After Xcode 9, it was changed, and it wasn't clear which database engine is used for now. Now let's talk about the server side specifically. And here I won't compare different integrations in terms of feature set because that's not interesting for me. They're all different. What's more interesting for me is the approach used for integrating if we're trying to look through the IDE glasses. So in this case, each of these integrations have more or less the same parts. It can be a language support, so for example for JavaScript, or the language support for specific languages inside the config file, such as Docker file. We may need to run and debug this code, which is true for JavaScript. Also, obviously, we can use some menus and actions and have some user interface integrated into IDE we are trying to create. And if we want to talk about the languages, the first-class citizens now are also HTML, CSS, JavaScript, and TypeScript, for example. And we need their support at the same level as we have for Swift and Objective-C, with all the code highlighting, code completion, and navigation features, because we also work with the front end. We may need support for specific web frameworks, like React, Bootstrap, and many others. Also, as I've said already, we may need to run and debug the JavaScript. And in terms of supporting such languages, I think from what I see, everything is pretty good because we have built-in support in Atom and VS Code, also many different plugins for some specific linters and other functionality. In the CLine and app code, we have a bundled part of the functionality. The history is interesting. So initially, all this part was bundled for the PhoneGap and Cordova developers, not for the server side, a long time ago. And in Xcode, we have a regex-based highlighting and completion, which is not that much. But I think that these and other integrations will be improved in the future because with such a big direction like a ServerSide.swift, they need to be integrated. Talking about web languages, we also need web templates. And web templates from the IDE view is a really interesting question because all of them are injected languages. An injected language is basically a language inside another language. So you have the base one, you have injected language. Inside this base language, you need to maintain the same feature set for them, and also sometimes you need to maintain an interoperability between such languages, which is very difficult to implement. So looks like everything is bad. That's not really true because we have an easy approach, and I also want to share it. So for example, if you want to make a framework dealing with web templates, there are some simple steps to consider for integrating it into existing IDEs and editors. First, try to support existing ones, because most probably they are already integrated, and it will just make easier for users to adopt your own framework and to start working with it. But next, you may need your custom templates, how to integrate it into the IDE easily. And the best approach is to make a simple text-made grammar, because it's really fast to create, and what's more important, it provides a simple code highlighting and code completion in all the editors, all the IDEs. It's supported everywhere, in VS Code, in Atom, even, as far as I remember, in Sublime also. In our IDEs, it's supported also. Finally, the final step is make separate plugins if you want the maximum, but that's very difficult. The current state is good. In AppCode CLine, we support handlebars mustache, Markdown only in terms of the injected language, so we won't have a completion and highlighting for HTML. The same is true for stencil, because we will have only highlighting for stencil as an injected language, no code highlighting for the HTML, but that's just our limitation, and that should be improved. In VS Code, in Atom, we have even more. We have handlebars mustache support, Markdown also in terms of only injected language, and also stencil and leaf bundles that provide, as far as I remember, code highlighting, and for stencil also code completion via snippets made by Steven. So we can work with the front end. Now we need to work with the back end, and here we need databases, and we also need to have them integrated. And is it only about SQLite now? I don't think so, because more or less we need something like this. And this screenshot from the VS Code shows what we can expect as an integration. We can have a view showing the database structure, results from our queries, query builders, code assistance for writing SQL queries, and so on. And here we have, I'd say, a good integration for the VS Code, separate plugins for separate database engines. For Atom, the situation is a bit different. We have plugins for almost the same databases, but one of them created a core for many small plugins and used this core plugin for integrating smaller plugins supporting specific database engine. That's interesting. We recently bundled the same functionality into AppCode and CLine, the same functionality for many IntelliJ databases. And that was one of the steps we made specifically because we now have the ServerSide.swift direction. Because previously it was only SQLite for mobile development, and AppCode initially only a mobile IDE. And for now we have more databases, and we can just reuse the whole part responsible for that. But now we need also to deploy our code and our apps. We need a Docker, and Docker also can be integrated into an IDE. So we can have a code completion for Docker files, views for containers, images, various consoles, logs, and we can also work with them from the IDE. Here we have a plugin integrated into AppCode and CLine. Initially it wasn't integrated because we had no use case for that. But after Swift started to work on server, we decided to add it because that's valuable for users. In VS Code, we have a VS Code Docker extension with almost the same functionality, also rich views and ability to edit Docker files and Docker Compose files with syntax highlighting for YAML files. In Atom, that's Atom Docker extension with several small plugins for some specific tasks, like also code highlighting for Docker Compose files and some build actions, like building the Docker file. But in addition to that, we can test our server-side applications on local and remote servers, so that's SSH, FTP, and various clouds. Here the situation is more or less good. In Atom, we have a part of the nucleate responsible for setting up SSH and FTP connections, and what's more, it allows to sync code changes to the remote server, so you can immediately see all the changes. Same we have for the VS Code with SFTP extension, and for the AppCode and CLine, we also have the same. We have a bundled part of the platform functionality. This plugin was bundled also just because the ServerSide.swift appeared. It was one of the many different steps. Talking about clouds, we can have a specific integrations for them, but here I'd say I haven't found a lot of them. I can say that we in AppCode and CLine consider adding just another part from the platform functionality, for example, for Heroku clouds, maybe for some others, if we have it in the platform, but that's to be improved. That's some future thing. Request testing. Request testing is interesting from the IDE perspective because initially, for example, for for different editors and IDEs, we have clients with different views, different buttons, different settings that allow you to work with requests from the UI, to build them, to test them, and so on. And for now, we have the same format for almost all the IDEs and all the editors used in this talk, and HTTP files. So they contain pure HTTP requests, you can execute them, get results in some formatted form, and that's, in my opinion, a very flexible approach. So you also can work with them as with the code, and it's really easy to execute a bunch of them or run a separate request. In VS Code, that's the VS Code REST client extension, by the way. In Atom, we have a REST extension and also REST client extension that doesn't work with HTTP files, but has a UI for building such requests. In AppCode and CLine, what's interesting, that's some historic thing. We had both, because initially it was a complex UI allowing you to build all the requests, formatting responses, but then it was just converted to HTTP files, and it's much flexible and I think easier to use. So that's enough about integrations, but what I was talking about are plugins, 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 plugins. So more technologies, more different frameworks. And because we now have not only mobile development, not only macOS development, we have also Linux, we have more frameworks, more technologies. One of the main challenges for now is a good plugin infrastructure for IDE creators, because we have lots of different new things that needs to be integrated. For some of them, we already need separate applications. We may need them, but say we have an application for working with request testing. Next we have an application for editing Swift code, an IDE. Next, maybe another IDE for editing HTML. Next, we switch to the command line. Next, we are trying to avoid using any IDE at all, because all these separate applications lead to destruction. There are too many of them, and it's also hard to maintain the same stack across different operation systems. We already have macOS and Linux. What's next with Windows, for example? So from the IDE perspective, we need to integrate it, or at least try to do it. But the problem is that it's not possible to integrate everything, each of these new directions by yourself. But here is an obvious answer. So what to do if you need a good plugin infrastructure? Have an open API. That's the thing that VS Code and Atom have. That's what we also have, for example, in IntelliJ platform, because if you compare the open source part working with the source code, with different IDE views and so on, with the private part used in specific IDEs, this part is very small, and this is really big because that's the core for working with the language. But even if you have a private API, and even if you cannot share it for some reason, like, for example, you can't maintain the backwards compatibility, and you can be sure that the developers working on plugin integrations won't have something broken, there is a solution. So just share these APIs with those who are interested and help them. And that's it, because that's what we do. If we see some developer wanting to create a plugin, we just get in touch, trying to help, trying to share some of these specific APIs that are private for now, because we just can't share them. And we have such integrations working, for example, also with run configurations. One of the examples was a SwiftLint plugin. Initially, I started its development, then I had no time to finish it. And then there was a mobile developer from the community, Alex Babayev, who took this project and made a great plugin integrating the SwiftLint into the editor. So that's it. There are many different topics, so I decided to make a list of all the different extensions, all the materials used, all the issues, and to combine them into this article. If you're interested, you can just see it here. Please do not assume this list as a list of the best of the best of the best extensions for working with something. That's just the list used for this talk, and I may be wrong here. If I am wrong, tell me, I will improve it. That's it.